Assalamualaikum and hi. Today we will go on chapter tutorial 2. We go tutorial 2. So basically, I give you 17 question, but for this session, I only give you the solution for till question number 9. Okay. Now, question number 1. We say question number 1. Okay, single sideband was introduced to overcome the disadvantage of AM double sideband. Justify how this AM as single sideband is better than AM double sideband. Okay, so this is the answer. Okay, question number 1. Theory. Now we go to question number 2. Okay, question number 2. A 100 kHz carrier having amplitude 50 volt is modulated by 3 kHz audio signal that having amplitude 20 volt. So now determine the maximum and minimum amplitude. Direct formula VC plus VM got 70. Okay, because of what? 50 plus 20. Okay, VC minus VM. 50 minus 20. So, and then sketch the envelope produced. This is how to draw. Okay. Now, the next question, calculate the modulation factor and percentage of modulation. Okay. So, M, VM over V, C. Remember in class, I'm telling you M equals to what? Monkey, right? C over, this is 1 over car. Okay. So, VM over V, VC. You take VM, divide by VC. So, you got 0.4. Okay. And the percentage of modulation, you take 0.4 times 100, got 50%. Okay. Number 3, distinguish the frequency that will show up in the spectral analysis in the modulated of the modulated. So you got FC. We want to know every element. FC 180 kilohertz from here. FM 3 kilohertz. Okay. F upper side band, F lower side band. Okay, now go to question number 4. Construct the mathematical expression of the modulated wave. So this is the answer. Okay. Now, draw the voltage and spectrum of the modulated wave. Here FC. Here F upper side band. Here F lower side band. Must be like this. Now, and then draw the voltage and the frequency spectrum of the modulated wave. Okay, you draw like this. Okay. Now and then discuss what will happen if the modulated wave, if the amplitude of the audio signal increase higher than amplitude of the carrier signal. Okay, will be like this. Okay. You discuss in terms of this. Up to you. Okay. This is open-ended question. Now we go to question number 3. Okay, question number 3. A bandwidth of 100 kHz is to be considered for the transmission of AM signal. If the highest audio frequency is used to modulate the carrier is 5 kHz. Determine how many stations could be broadcast. Okay, so bandwidth 100 kHz and then bandwidth allocated for the station to FM. 2 times 5K, so you got 10 kHz. Number of station, you take the given bandwidth 100 kHz divide by 10. Okay, so you got 10 station. Now we go to question number 4. Okay, question number 4. Two input amplitude modulator given as V1 10 sin 2 pi to 100k t and V2 2 sin 2 pi to 100 kt. Construct the mathematical expression of the modulated signal VAM t. So this is the question 4. This is the information you extract from here, where VM equals to 2. You already know why I'm already telling in class. VM lesser than VC. So you extract information, you find the modulation index, and then you put in the AM equation like this. Okay. So we go to question 5. Question 5. Okay, question 5. Given the amplitude of the AM modulator is modulated wave with a maximum and minimum positive envelope 30 and 20 volt. Okay, the carrier frequency is 500 kHz and the audio signal 5 kHz. The equivalent resistance of the transmitting antenna 50 ohm. Okay, evaluate the peak amplitude of the carrier, outdo and sideband voltage. Okay, so direct formula you take here VC. Okay, Vmax plus Vmin over divided by 2. Vm, Vmax minus Vmin over 2. Okay, and then V upper sideband equals to V lower sideband. Vmax minus Vmin divided by 4. I already given this derivation. I said something like equation 1 minus equation 2. Refer back in your slide. In your tutorial. I already give you before this. Okay. Now, so you got this formula. Okay, now you got this answer. Okay, now we go to modulation index. Modulation index very easy. Vm divided by Vc. Vm, how many? What is the value of Vm? 5 divided by 25. You got 0.2. Okay, number 3, power of the carrier signal, total sideband power and also total power. Okay, now 5.3. So the carrier signal. P carrier Vc squared over 2R. You put all the value here, you got 6.25 watt. Okay, this one sideband. Sideband means P transmit sideband, M squared over 2P PC. You got the formula. And then power transmit equals to PC plus P T sideband. So you got this formula. Okay, 5.3. And then 5.4. Okay, 5.4, you find the power formula. Okay, and then you find upper sideband, lower sideband. Use cache. Okay, use cache the level power spectrum. Here side of frequency. Here power in term of power. Okay, then we discuss what happened that if to the modulation index and the sideband amplitude when the minimum positive envelope change to 0. Means you must put in you must know this formula, and then you put what happened if Vmin equals to 0. Okay, from formula you can verify. So this is the discussion. Can be in other form. Okay. Now we go to question number 6. Question 6. In question 6. An antenna transmit 10 kilowatt power at this 95% modulation. So what is this? You know, you already know if M, small m, means 0.95 modulation index. Okay, evaluate the amount power saving in the single sideband suppressed carrier. Means single sideband suppressed carrier. Means no carrier. Okay, so what happened? You take PT. Okay, M equals this formula. Okay, use this direct formula, single sideband. You check back in slide, and then power save. Remember, we concern right now. When you double sideband use a lot of power because you got power transmit, power upper sideband, power lower sideband. Single sideband, single for SSB. We reduce means single sideband suppressed carrier mean carrier not appear. So you can see this formula, direct formula question 6. Now we go to question 7. Question 7 actually open-ended. Okay, if you find something new and so on, you can elaborate by yourself. Okay. Now question number 8. For particular broadcast AM radio station with a carrier frequency of 80 sine 2 pi times 10 power of 5 pi t and modulating signal. Okay, right now, if you don't understand, remember what I'm telling you before. 80 and 20. Which one bigger? This one bigger. Bigger means all of this in carrier signal. This one information signal or modulating signal. Okay, from here, question number 8, direct formula means modulation index. Vm over Vc. What is the Vm? Vm 20. Okay, divided by 80. So you got 0.25. And then maximum and minimum envelopes. Okay, Vmax, Vc plus Vm. Vc, what is the Vc? Vc 80 plus 20, Vmin 100. Vmin, Vc minus Vm 80. This one Vc, right? 80 minus 20 equals to 60. Now, how about the 83 sideband frequencies? Mean we want to know the sideband frequencies. Okay, so you know Fc, right? Fc. Okay, and then everything you found everything but from frequency you put here. Okay, and then you do analysis, you find FC, FM, upper sideband and lower sideband. Complete. Okay, 8-4. Amplitude of each sideband. Okay, 8-4. Okay, amplitude of each sideband frequency. Okay, you use this formula. Okay, you can do this analysis. From here, you can find VM, and then V upper sideband equals to V lower sideband. VM divided by 2, 20 but divided by 2. So you got 10 volt. And then from here, you can further extend VM equals to 20, 20, and then FM equals to 5 Hz, 250 Hz. VC, 80, and then FC equals to what? FC equals to 1 time here, FC. Oh, I think this one wrong. And this one actually 2. Okay, sorry, I made a mistake. This one actually 2. Okay, because I put here 2. Actually, this one 2. Okay, so I made mistake here. So, and then what happened? You put in the analysis, you got this formula. You put in the AM formula. IV, and V. Now we go to VI. VI equals to what? You want to draw VI, illustrate and label the output envelope of the modulated signal. Okay. You draw like this. You put Vmax, you put Vmin, something like this. Okay. 8 IV, 8 VI. Now VII, bandwidth, direct formula to FM. Okay. 500 Hz. VII, the total power delivered into load of 600. Okay, 600. You put direct formula VC squared divided by 2R. You got this formula. M VM over VC 0.25, and then you got power transmit. Now discuss. Okay, power saving. One more. This one important. Power saving very important. We want to know the power saving. Now, please see the answer. Please see the question. Power save if one sideband is suppressed. Mean one sideband is suppressed. Okay. So use this formula. You got this answer. Power save and then percentage of save. Okay. For X. Okay. Discuss the method available to achieve single sideband amplitude modulation. Okay. So this is the answer. If you got the another answer, no problem. Okay. Okay. Question 9. The antenna current of the AM broadcast transmitter modulate at the depths of 85%. This one, depth 85%. So you know what is this? 85% means this modulation index, and then fed into 50 ohm antenna load, and then it's a 10 ampere. Calculate the modulated output current. See. So this is formula direct put. For the formula, you got this formula, and then calculate the power, the total output power, PT IT squared times R. R equals to 50 ohm. So you got this formula. Okay, thank you. If you got any problem, you can asking me. Thank you.